Is an atomic bomb the principle that energy is generated by light and heat generated by the collapse of uranium by weak nuclear force? An atomic bomb explodes by emitting light and thermal energy by fission reactions that occur by collapsing uranium atoms. In this reaction, the uranium nucleus absorbs neutrons and splits, releasing a large amount of energy. This released energy causes a big wave in the surrounding environment and explodes. So, an atomic bomb is generated by a strong nuclear force, not a weak nuclear force. What is the principle of a hydrogen bomb? Hydrogen bombs, or H-bombs, are inorganic explosives that generate energy by fusion reactions. These explosions typically proceed in a pathway that is fused into helium-4 with 2 neutrons. Hydrogen bombs use energy generated by forcing 2 separate nuclei, the lighter nuclei of hydrogen atoms, into high temperature and high pressure. In hydrogen bombs, pressure is first created using TNT, which is usually an explosive. Because of this pressure, hydrogen nuclei approach each other, and subsequent collisions release a huge amount of energy. The energy emitted in this process is divided into heat and photons, which are energy caused by molecular motion of chemicals, and photons are electromagnetic waves emitted as electrons move. This released energy reacts with the surrounding air, causing explosive waves, and large waves are observed in the form of explosive clouds. So the materials used in atomic bombs and hydrogen bombs are uranium-238? In the case of atomic bombs, fission materials such as plutonium-239, uranium-235 are mainly used. Uranium-238 is not used in fission reactions because uranium-238 is a stable nuclide and does not cause fission reactions. In the case of hydrogen bombs, hydrogen and its isotopes deuterium and tritium are used because they use the heat and pressure generated by the fusion reaction of hydrogen to cause explosions. These hydrogen elements produce neutrons that are released when detonated, and they use them to maintain a fusion reaction. Therefore, hydrogen bombs use hydrogen elements necessary for fusion reactions, and fission materials such as uranium-238 are not used. Do atomic bombs and hydrogen bombs also have half-life? So does their destructive power weaken over time? Atomic bombs and hydrogen bombs are weapons that explode using fission and fusion reactions, and they do not use nuclides that are directly related to the half-life. Therefore, the destructive power of these weapons has nothing to do with the half-life. However, radioactive materials or explosive debris released during an explosion can continuously emit radioactivity for a certain period of time. If these radioactive substances are exposed to the human body, they may be affected by radiation, so care must be taken. In addition, buildings and structures may be destroyed by fire and explosion waves generated in the event of an explosion, and there is a possibility of a fire, so the risk of the explosion may continue even after the explosion. How many decades after the development of the worm bomb will the explosive power be weakened? Or should I replace it? The worm bomb is a nuclear weapon using a fusion reaction, and explosive power is a major performance indicator. In the case of the worm bomb, neutrons produced by the fusion reaction are used to trigger more fusion reactions, which require the use of tritium and deuterium, nuclear materials with high energy inside the worm bomb. The tritium and deuterium used inside the worm bomb do not have a half-life, and are not directly related to the weakening of the explosive power. Therefore, after developing the worm bomb, the existing explosive power can be maintained without replacement. However, since nuclear weapons are made up of very complex and sophisticated systems, regular inspections and maintenance are required if they need to be preserved for a long time. In addition, proper storage and management are required to ensure the safety and security of nuclear weapons, and continuous efforts are required. What is radioactivity? Radioactivity is a term that refers to the force of electromagnetic waves or particles emitted from atoms or molecules. These radiations usually occur in radioactive materials and are divided into natural and artificial radiation. Natural radioactivity occurs in radioisotopes and cosmic rays inside the Earth. These natural radiations are something that we are exposed to a lot on a daily basis, and radioactivity is released from the ground, air, and plants, and exists around us for a long time. Artificial radiation occurs from human-generated radioisotopes or radioactive materials. Such artificial radiation occurs in nuclear tests, nuclear power plants, and radiation treatments, and can adversely affect human health depending on the type and concentration of radiation. Radioactivity can destroy or mutate cell DNA or cell structure, causing diseases such as cancer. Therefore, appropriate protective devices and radiation safety rules are needed to properly manage and safely use radiation.